Hello everyone and welcome to EPulse Academy. In today's episode, we are going to explore the basics of electrical circuits and networks. By the end of this video, you will clearly understand concepts such as schematics, branches and nodes, short circuits and open circuits, and finally, we'll talk about a complete circuit. With that being said, let's get started. What are schematics? Now, a schematic is a drawing of a circuit that shows how electrical components are connected. Instead of drawing the real physical shapes of components, engineers use special symbols to represent them. Components like resistors, capacitors, and power sources use standard symbols as their representation. Schematics clearly shows how components are connected, and it describes the path through which electrical current flows in a circuit. Some examples of schematic diagrams include a simple circuit system, power supply circuits, and electronic devices like the amplifier circuit. Without schematic diagrams, analyzing complex circuits will be extremely difficult. When studying circuits, engineers often divide them into smaller parts to make analysis easier. The two most important concepts used in circuit analysis are nodes and branches. A node is simply a point where two or more circuit elements are connected together. In circuit analysis, we usually measure voltage at a node with respect to a reference point, commonly known as ground. The ground node has a voltage defined as 0 volts. Therefore, in accordance to the figure above, the voltage at node V3 with respect to the reference point is equal to 0 volts. This allows electric current to flow in and out of the node through the components connected to them. A branch is defined as the path that connects two nodes and allows for electric current to flow. They usually contain components such as resistors, voltage sources, and current sources. The voltage across a branch is simply the difference between the voltages of the two nodes at its end. Understanding nodes and branches are extremely important when applying circuit analysis techniques like Kirchhoff's laws. Sometimes, circuits behave in unexpected ways because of conditions known as short circuits and open circuits. A short circuit occurs when there is direct connection between two or more nodes in a circuit. This creates a very low resistance path, allowing current to flow in large amounts, which can cause overheating, damage of components, or even electric fires. In many cases, short circuits happen unintentionally due to faulty wiring or damaged insulation. On the other hand, an open circuit occurs when there is no connection between two nodes. This creates no path for current to flow in that part of the circuit. This condition is unintentional and happens when wires break, switches are open, or when components fail to function. These conditions cause circuits not to operate properly. For electric current to flow, the circuit must form a complete loop. This is called complete or closed circuit. In other words, current must have a continuous path that starts from the source and returns back to the source. Consider an example of a lamp connected to a wall outlet. The power cord contains two conductors, the live conductor and the neutral conductor. Current flows from the socket through the live conductor, then passes through the light bulb. After that, the current returns through the neutral conductor back to the wall outlet and eventually to the power plant. This explains why a bird sitting on a single power line is safe, because it is touching only one conductor and there is no complete path for current to flow through its body. But when a ladder touches both the power line and the ground, it creates a complete path for current, which can be extremely dangerous. That is why electrical safety is so important. If this has helped you understand electrical fundamentals in a better way, Give this video a thumbs up and drop down your valuable comment below. Don't forget to subscribe because I would love to see you in the next episode. Stay curious and keep learning.